Alright, so this is going to be a quick tutorial on weighted averages, and I feel like the best way to teach what a weighted average is through using an example. So what I'm going to do here is using examples of these black spheres and this red sphere, because I'm doing Raider colors here. We're going to use this to actually figure out what the weighted average of these samples are. So if you look at these numbers, you might think that you just want to add the 50 grams and the 10 grams and divide it by 2 to get the average. If you do this, you get 60 grams divided by 2 to get the 30 grams. But this is actually not the weighted average of these samples here. What you need to do is you need to take into account that each one of these spheres is 10 grams. So then you're going to need to add 10 plus 10 plus 10 plus 10 plus 50, and then divide that by the 5 because we have 5 spheres total. Okay, so then you would end up with 90 divided by 5, and you'd have 18. But the whole point of this video basically is to show how percent abundance is related to the weighted average. So what we're going to do here is I'm going to break this down, these 10s. I'm just going to simplify it and do 4 times 10 plus 1 times 50 divided by 5. So we have 4 times 10, which is just the 10 plus 10 plus 10 plus 10, and then the 1 times 50 for the 50. Now what I'm going to do from here is I'm going to distribute this 5 out. So I'm going to do this whole thing divided by 5, and this whole thing divided by 5, and then add them together. So it's going to look like this: 4 times 10 divided by 5 plus 1 times 50 divided by 5. Okay, so from here, I'm going to simplify this 4 divided by 5 and this 1 divided by 5 and turn them into percents. So 4 divided by 5, hopefully you know that it's 80%. And by doing that, I just did 4 divided by 5, multiply it by 100% to actually get the 80%. Bring this 10 down, so it's 80% times 10, plus 1 divided by 5, which is going to be 20%. Again, you can check that on your calculator. Times, I'm going to bring this 50 down right here. Now if you notice, I'm not dividing anymore. Over here I was dividing by 5. Here I'm no longer dividing because I turned both of these into percents. And if you notice, both of these percents add up to 100. So I'm actually including all the spheres in this problem. Okay, from here, you can do 80% times 10, or 0.8 times 10. You'll get 8. And then you're going to add this to the 20%, or 0.2 times the 50 to get 10. 8 plus 10 equals 18. And if you notice, you get the same answer regardless, but it's different than the first average that we got of 30. Another thing I want you to kind of see is the answer 18 we got here is closer to the 10 grams than the 50 grams. And the reason for this is because there's more 10 grams in this sample than the 50 grams. So because of that, the answer you get for the weighted average is going to be closer to the 10. Now the reason I want you guys doing this in percentages, and because in chemistry you're not going to see these easy numbers where there's just 5 samples. You're going to see samples of thousands, of millions, of billions, because we're dealing with atoms here. So I'm just basically showing how these percentages are related to the weighted averages, because that's what you're going to mostly get is percentages. It's going to make more sense in the next video. If you have any questions on this one, let me know.